Hello and welcome to episode number 239 of the Armin Show podcast. We are here with the author of this wonderful book. People have said I should hold the book up longer for the video. This is the book, Rethinking Consciousness, Michael Graziano, author, professor at Princeton University, Neuroscience and Psychology. Welcome to the show.
Thank you. It's a pleasure to be here.
This is a great thing. Now, I like neuroscience. A lot of my people I've spoken with, it's in the category of neuroscience, the brain, human behavior. I'm always interested in it. What led you into this category in the first place? How early on did you know you cared about the brain and how we process things?
Right. I think I've always been fascinated with the brain, probably as far back as I can remember. I tried out a number of different topics, though. I mean, I studied physics. I was a physics major in college. And I wrote fiction and studied that, and I studied music, and it took me a while to sort of settle down. But neuroscience, what I like about neuroscience is that you can't throw a stone without hitting a mystery. So it kind of makes it a very exciting place to be.
Mm-hmm. Now, one thing that's very cool, and I know that sets you apart in one of the ways is, and you can see it in the background there, there's a piano, a keyboard, if you will. You have various other interests you have connected with, like writing, I believe, children's books or novels, and then making music. Can you speak about some of your other interests separate from neuroscience in the first place?
Sure. I mean, I've studied music. I studied music composition particularly, and I write music, and you can check it out if you want. I have a YouTube channel that you can look up, and I have some of my music on there, and I enjoy it. It's great fun. I think it was just always very, very interested and very curious about it. You know, when you're a kid, you hear music, and I always used to think, how do they do that? Like, what is, if you lifted up the hood, what's under there? How do you understand a symphony? It seems so complex. What's the inner workings of a symphony or a string quartet or whatever it is you're listening to? And I think I was just very curious about that. And fiction as well. I've been writing fiction for a while. Yes, I have children's books out there, and I have also novels more for a more adult audience. So. But what I found over time was it's much easier to write music on the side than it is to be a musician and do neuroscience in your garage or something like that, which is kind of impossible. So as a career choice, the science ended up being the main thing that I focused on.
That makes sense. Did you start to look at it mathematically in some form, the music? At some point, like the notes and like half notes above or an octave, things like that?
I didn't really. So I think there are people who have looked at music very mathematically. I mean, there's a whole school of thought in 20th century music, this 12-tone school of thought, which is very mathematical. And I think music is fundamentally aesthetic and emotional, and that I approach it that way. But it is also true that when you do anything at all, music, writing, science, whatever it is that you do, there's always an element of craftsmanship about it, which requires a certain amount of organization and structure and logical thinking. So you kind of got to put both together.
That makes sense. Yeah, it can't just be one, art and the science together. Also for the fictional books, I always wonder about this. Do you include parts of your own existence in the fiction, or do you create a story from scratch that has no relation to yourself?
I think all fiction is in some way autobiographical because you're always pulling something out of your own perspective. And my fiction is very surreal. And so I hope it's not literally autobiographical because it's really bizarre. but but it has to come. I think all fiction comes in some sense from an autobiographical point of view.
Yeah, that makes sense. It's hard. It's really hard to just disconnect from yourself and create some sort of external, completely separate thing.
Yeah, I think that's impossible, actually.
Yeah, it's like, right. I'll just go with it being impossible as well. That's a good point. Now, so you are a professor at Princeton. How did you get to that point, and how long have you taught there, and what do you teach there?
So I teach neuroscience, and I'm in both the neuroscience and psychology department, so kind of one foot in each. And as a psychologist, I'm much more on the neuroscience end. And I when I started doing neuroscience as an undergrad, so I was a physics major, working away, getting a little bored because everywhere you look in physics, things have been figured out, and it's hard to find a mystery that you can actually contribute to. Uh, so at some point, I began to work in a lab on neuroscience, on the actually visual processing in the brain, and it was very exciting, and it was that drew me into it. And from then on, I concentrated more on neuroscience and continued on as a graduate student, postdoc, and so on at Princeton. And so I've just sort of been here the whole time.
That makes sense. One thing that just came to mind as you said that is physics didn't offer you many affordances, as you mentioned in the book, or opportunities,
Right,
specific opportunities for
right.
action that you saw, like open space. That's a cool feature. Now you run the Graziano Lab, which is based on yourself. What are some things you're working on in that lab at this current time?
So the fundamental question in our lab is, well, what is consciousness? That's the question. And the way we think of it as neuroscientists, the brain's this big biological machine that thinks it has all kinds of remarkable properties, many of which it doesn't have, some of which it does have. But we want to know, why does this machine think it has an essentially magical consciousness property? And what good does that do it? You know, is there some cognitive use to that kind of self model? And that's what we study. We study networks in the brain, we study human behavior, and we study the conceptual underpinnings of what this consciousness thing is.
That makes sense. One cool thing as I was reading through your book was that there was some connection with something I've always thought of about the brain, and then also I recently spoke with a professor in England, Nick Chater. I don't know if you know of him, but his book is called "The Mind Is Flat: The Illusion of Mental Depth," which it kind of relates to. We add these layers of mental depth that maybe it's not the case, but you specifically focus on the concept of the attention you put on something, and then consciousness. We create a layer that attention is our consciousness above it. I don't know if I'm butchering it. Attention schema theory. How would you describe the theory that you have created?
Well, in its really most simplest form, uh, attention, and I often don't like the word attention. I just don't know what other word to use. But
Hmm.
it has many colloquial connotations that get in the way. Maybe one way to put it is there's such a thing as deep processing of information, deep
Hmm.
focused processing of information. And that is, brains are good at that. And computers can do that too. Um, Human brains are particularly good at that, deep focused processing of information. But uh, the brain does more than that. It does more than process information. It also builds models or simulations or descriptions of what it's doing. And those descriptions are never accurate. They're always a little bit simplified. They're always kind of quick and dirty descriptions. And so the brain doesn't just focus its processing on something. It also is telling itself, this is what I'm doing right now. And when it's describing its own behavior, its own actions, it isn't saying to itself, I have 86 billion neurons and they're doing this and that and interacting. No, that's way too elaborated. Instead, the story the brain is telling itself is, I have a kind of a non-physical magic-y thing inside me that's aware of and conscious of that thing that I'm looking at, right? So when we talk about consciousness, when we talk about awareness, subjective awareness or consciousness, what is happening there is the brain providing itself with a simplified account of what it's actually doing. And that's in a nutshell what this underlying concept is. And then there's all kinds of connections and reasons why that kind of self-description is useful. So, but that's the core of the theory.
Mm-hmm. I noticed that in the book you described a frog with its eyes and its tongue and shooting out whatever it does. It just does and doesn't have a second layer where it calls itself its consciousness. It just goes. And then the animals that evolved at some point, dinosaurs and us mammals, it appears that consciousness showed up. What is the main distinction between what we have brought to the table versus some amoeba?
Right. So yes, the book traces the possible evolution, and we can only really speculate at this point, but we know a little bit about the information processing in the brains of these animals. We know a little bit about the frog brain and the fish brain and so on, and lizard brains. We know a bit about it. So the point is that a certain kind of really deep processing of information is present in some animals and not others. And so attention, it's typically called, certain kinds of attention are just not present in a frog. It can point its eyes at things, it can point its head at things, but it doesn't have this ability to focus its resources on a set of signals that may be a very abstract set of signals. So frogs probably don't have this, don't have these kinds of mechanisms. But you start to see this richer kind of attention coming in with maybe reptiles, but certainly you see it in birds and mammals who have a common ancestor in reptiles. And so both birds and mammals have these very sophisticated forms of attention, and therefore probably these very sophisticated self models of what attention is doing. And so we suspect that what we would recognize as conscious experience is probably present to some degree in almost all mammals, if not all, and probably birds as well. This vast range of animals have at least some form of what we're talking about.
That's a wonderful thing to know. We have a little bit more processing that's recently evolved. I always think about the prefrontal cortex as our most advanced section. In the theory, you have two functions that are main functions of it. One of them is that our brains process to help control attention, and then the other one is we monitor other people's attention. So what is one way that our brain helps control our own attention?
Imagine a scenario where, let me give you an analogy first. Mm-hmm. You have an arm. There it is, physical arm, moves around, does stuff. You also have a simulated arm. The brain constructs an arm model. It's a bundle of information. It's constantly changing, and it monitors and keeps track of your arm. And it's called the arm schema. And the brain uses it to be able to control your arm appropriately. And take out that arm schema, and some people actually, through a stroke or other damage, lose their arm schema, and their arm becomes useless. They don't even recognize it as belonging to their own body anymore. And they can move it, but not well. And it just sort of flaps there, and they have no feeling of ownership over it. So the arm schema monitors and helps control the arm. Now, what we're talking about, an attention schema, is the same kind of thing. The brain's monitoring and keeping track of how it's focusing its resources on this or that item. So it's the brain's attention is being modeled by this attention schema. And so without it, or when it fails, that attention schema fails, you would essentially have very poor attention control. So your attention would you would not be able to hold it on one item. You would not be able to resist having it flip over to something else. You would not be able to keep it in one location instead of having it fuzz out. It would go haywire, right? So that's the idea. And one of the things we do is study these cases where people lose consciousness of really specific little items in front of them. And then we ask what happens to their ability to direct or control attention with respect to those items in front of them. And so that's what we see. If you're not conscious of something, then your attention is knocked around by that thing in uncontrolled ways.
Hmm. I always think about it like how much it takes so much of our, I guess, sugar resources or whatever we have to power just our main focus. That's where we're at that moment. And then there isn't so much multitasking going on. There's subconscious, but there's not so much
Right.
extra happening. The
Yeah.
other function described in your theory is that it monitors yours and others' attention as compared to one another for behavioral prediction. Can you speak on that concept?
Sure. So when people study consciousness, often they're thinking about something private, like my own internal consciousness. But humans, at least, use this whole idea, this whole construct in a one of the ways we use it most is attributing consciousness to other people. And it's a huge part of social intelligence. It's a huge part of how we understand other people and make predictions about them. We attribute a conscious mind to other people. So I'm talking to you, and I have this intuitive, kind of reflexive way of attributing consciousness to you. I just sort of know at a deep level that you are a conscious being, and it affects how I interact with you. It allows me to make some predictions about your behavior, because if I think you're conscious of something, then I can start to predict how you might react to the something. If I think you're not conscious of it, I don't know, we're driving down the road and I think you're not aware of a road sign, then I start making a different set of predictions about how you'll behave. And so it's very, very important. It's central to our social intelligence that we perceive consciousness in other people. And humans have developed this to an extraordinary degree. We attribute consciousness at the drop of a hat. If it has eyes and sort of moves in a complicated way, we attribute consciousness to it. Sometimes even if it doesn't have eyes, right? I mean, people talk to their house plants and swear that they have consciousness. And I got mad at my computer the other day because at some deep intuitive reflexive level, something in me assumes the computer's conscious and is trying to harm me in some way. So we're prone to this because we're social animals, and we evolved with this social machinery that projects consciousness onto the objects and people around us.
Huh. That brings to mind a few things, like some individuals do this with, let's say, dogs that might not have as much processing ability as us, but they'll attribute so much more because it's just built in. Let's give qualities. Or like a comedian, if they do a joke and people don't pick it up, they suddenly adjust to the level that they feel like it'll resonate with the audience. We're always attuned to
Yes.
who are we around.
Yes.
That's kind of cool. It's a sign of intelligence too, like how much you adjust because you understand.
Yes.
What am I interacting with? That's a cool feature. You talked about in the book incoming signals and how they compete with each other on their way in. What kind of competition occurs in that form?
So one of the really interesting stories in neuroscience in, I don't know, the past 20 years, let's say, or more even, is the basis, the mechanism behind attention. So why do we need attention? Why do we need to focus on one thing? Well, if we didn't, then to process the whole world around us, we need a brain, the size of a Buick or something. I mean, you need a lot of processing power. But the secret to intelligence, the secret to a truly intelligent brain is efficiency, is taking whatever you have here and focusing it so that you can intelligently and deeply process one thing at a time, or a small number of things at a time. And so that's what attention is. It's this ability to focus in on the most important thing at the moment. So how do we do that? It turns out the brain is like a big series of competitions. Signals come in, like visual signals and auditory signals and so on. They come in, or internally generated signals, thoughts and memories, and they start competing with each other. that is, the actual neural signals are in competition, where one signal is always trying to rise up and suppress its neighbors. It's almost like a big election where all the candidates are fighting with each other and somebody's trying to come out on top and beat down the competitors. And by going through layers and layers and layers of competition through neural networks, these signals slowly sort themselves until one or a small number rise up and win everything. And those are the ones that the brain organizes its processing power around. So attention is this self-organizing process of competition, signal competition. And that's something that's been studied in minute detail at the level of individual neurons in the brain. So that's a really interesting, a really cool story in neuroscience.
Mm-hmm. I've thought about that many a time. For our brain, like there's a bunch of little decision trees that are battling one another, and then as a collective consciousness of all the people that the signals that are able to outdo the other ones, those are the ones that rise in that bigger brain, I guess, sort of combined together.
Right.
It's like a biased competition, as you refer to it, from neuroscientist Robert Desimone,
Yes.
described that way.
Yes.
We have two kinds of attention, overt and covert attention. One of them is underneath the radar, and one of them is straight attention. Can you describe the difference between those
Sure.
two?
So overt attention is basically where you're looking. Or if you don't have eyes, if you're a creature that's mostly ears, it's where you point your ears at. I mean, overt attention is, yeah, the sensory systems are big satellite dishes. And so one way to filter information is just to point them at an interesting thing. And then everything else in the world kind of is not processed. And the thing you're pointing at is. That's a simple way to solve the attention problem. But we have this thing called covert attention, another way in which mammals and birds differ from, say, frogs. We have covert attention. And covert attention is the ability to not focus our eyes, but focus our mind on something. For example, you may be looking straight at someone, but your attention is on something completely different. So you're looking straight at someone's face, but you're thinking about an itch on the bottom of your foot, or you're looking at a book. Like that's where your eyes are pointed, but your mind is on some conversation you had yesterday, right? So, or even you're focused on something you can see, but it's off to the side, but your eyes are nailed to the center, but you're maybe talking to one person, but you're listening really hard to the guy over there who's saying something interesting, but you're not looking at him. You're just focusing your mind on him. And so this is basically what covert attention is. It's focusing the mind, really the cerebral cortex, focusing your cortical machinery on something that you're not necessarily pointing your eyes and ears at. And so that's a kind of the most sophisticated form of attention that we have. So,
I was just thinking about it in terms of paying attention. It almost seems like the covert attention was worth more than 50% of the total attention. When people focus both overt and covert attention on something, it's like amazing. That's like the really cool time of focus. Often it's more the case that overt is going as usual, and then covert is distracted elsewhere, and it's not so functionally efficient. Paying full attention in some form.
Right.
Now, the thing about affordance that you mentioned in the book, that one I identify with heavily because I see, like in life, there's a lot going on, but there's very little where it matters, or you have an ability to alter things or adjust things. There's little small white spaces in there, and these are affordances. How does our brain focus on these affordances or specific opportunities for action?
Right. So just to summarize the idea of an affordance, which Gibson, the psychologist Gibson, really popularized. So the idea of affordance is not what is out there, but what are my opportunities to act on it? Like a coffee cup offers the affordance of picking it up and drinking it. But it might also, if you want, I suppose it might provide the affordance of picking it up and throwing it. I don't know. I mean, there are different actions you can make on the same object, and some objects are there you go. Some objects are really full of affordances that are very important to us, and some not so much. You know, a donut, something we're very interested in, affordance. A tree branch to a bird is something you land on and grab with your feet, right? And so what's important for the person or animal is encoding the properties of the stimulus in a way that's action oriented and not just passively what is the world like around me, but what are the action opportunities for me out there. And so that's very much how our brains work. So when your system, when you look at something, when you look at an apple and your visual system processes that apple, ultimately it's not just coming up with a description of an object. Everything in the visual system is geared toward these associations between what you see and what you can do to it. And so that's really where affordance comes in. The whole brain is a big affordance machine. It's just, that's our job in the world, is not to see the world for what it is, but to see the world for what opportunities it affords us.
It's nice. Many years ago, I would think of our brain as just stimulus comes in, we do a little processing and send out a response. But that wonderful level of processing and examining what's important and how much I'll focus on it, that's what we do. That's our super ability in some form.
Yes, yes.
You have described that consciousness, or multiple people have described the consciousness is a hard problem because you can't confirm it from the outside. It's a private experience. Is there any way to get in there, I guess, at some point and like the other person, have the other person see what you see? Is there any thoughts in that category?
I think that the mind is information, right? So I've described it as like a trillion stranded sculpture made out of information, and it's constantly changing and adapting to the world out there. But that's what the mind is. It is information, and information is something that you can, in theory, confirm from the outside. I mean, it's such complex information, we don't know how to do that yet. Like, we could do that for a very simple brain or a very simple machine. We could probe it and measure the information in it. The human brain, not yet. But in principle, you could go in there and see what is in there. I think what's happened is, on the consciousness topic, so we're convinced, us brains, us human brains, us biological machines, we're convinced that we have a non-physical magic inside of us. It's basically non-physical. Non-physical in the sense you can't push on it and measure a reaction force. You can't break it and measure its tensile strength. It's just there, floating in us. And that concept, I think, is, well, I'm not the only one who thinks this, that concept is not quite right. Like, that's what the brain thinks of itself, because that's a useful simplification. And so the hard problem of consciousness is usually formulated in this way. How can we ever scientifically study something that's non-physical and kind of floating inside of us? And the answer is, A, we can't, and B, it's not there. But what we can do is understand at a specific scientific and mechanistic level why the machine thinks it has that property, right? So the hard problem is something that a lot of us are not terribly impressed by. So it's one way to put it is we can begin to explain why people mistakenly think there is a hard problem.
That makes sense. I'm also with the same concept. I feel like they're all at a small enough view. It would be, oh, I see this, I see the connection there. It would just be there. So I don't really have that view that it's some extended thing. Also, do you extend this thought into, I think of people's mind, like, for example, a brand that's popular, I just think about it like that brand description is encoded in 80 million people's minds, and that makes it what we call popular. And if we just erase that from 80 million people's minds, that little portion, suddenly that brand would no longer be. Do you think about minds in terms of like that?
Uh, if I'm not 100% sure what you mean, um,
Like we have certain memories of a location or a certain company brand somewhere in our brain encoded somewhere because it's physically there. So if somehow those molecules were moved or adjusted or erased, then that you could erase that from 50
yeah,
million people if there was a physical removal.
that yes, for sure. Yes, these memories and concepts and beliefs and thoughts, they're all instantiated in very specific hardware. I mean, they are the product of neurons interacting in specific ways via connections, synaptic connections. And if you alter those physical connections and that physical hardware, you would definitely erase those thoughts, concepts, emotions, everything else. It all depends on that hardware. Yes.
Now, in your lab where you do research, where is the most research done? Is it on other animals? Is it on people who have had some sort of brain damage? Is it on like schematic concepts, or how is it done usually?
So what I do is I study humans.
Hmm.
Uh, I don't know how to study consciousness in animals that don't talk about it. Some people do, but I think it takes a lot of sort of assumptions that
Right.
don't that are a little strained. So I study people. I typically do behavioral studies, that is, people answering questions or pressing buttons or looking at stuff on a screen, and then typically I'll take that behavior and put it in a scanner, an MRI scanner, and then we start looking at what brain networks are involved and how different parts of the brain interact with each other during these kinds of tasks. So that's the kind of thing we do, and that's been very interesting. I mean, there's parts of the brain that are involved in social thinking that have been studied for a while in social cognition, it's called. And those are the parts of the brain that also show up when people start talking about their own consciousness. And so we get this very strong sense now that uh, our own consciousness and the consciousness we project onto other people, all of this is coming from a set of information built by the same networks in the brain.
In that kind of research, what other categories of science do you mesh with any other categories of science in connection with your own research?
Uh, well, it's definitely an intersection, right?
Hmm.
It's an intersection of psychology and neuroscience, social neuroscience, and sensory neuroscience. A lot of what we do is visual consciousness. Are you conscious of this color in that spot? Um, a lot of what we do is social neuroscience. What do you think about this other person, and is he aware of this or that? Um, it intersects with philosophy, of course. Um, and so it intersects with engineering. So the core ideas here is the brain is a big machine that controls stuff. And one of the most fundamental principles of control engineering is the control system should have models or simulations of the thing it's controlling. And that's the whole heart of this theory is the brain has simulations of itself because it's controlling itself.
Hmm.
And those simulations are always simplified. They're kind of cartoonish self models. And that's engineering. That's straight from control engineering. So actually quite a few different branches of science and evolutionary biology as well, all kind of converge and glom together on this the topic of consciousness.
Hmm. Have you, has there been any books that have been important early on or that you liked a lot, or any scientists that you identified a lot with along the way?
On this topic of consciousness, I think it's uh, I think the field is inventing itself anew right now, and a lot of the previous work has kind of gone in the wrong direction.
Oh,
right? So the classic question is, how does a brain produce this magic essence, right? And almost all theories have focused on that. And basically, what's happening now in my work, and I'm very happy to see lots of other people's work now, what's really happening is, okay, it doesn't produce magic, but why does the brain think it does? Right? So it's a totally different approach. And that means it's actually not that easy to find inspiration directly on this topic of consciousness. Um, but on neuroscience in general and science in general, sure, there's lots of wonderful, brilliant work out there that's, very, very inspirational.
I like how you brought that up. I could almost do a whole thing just talking about the questions that we ask. When a question is set up in a certain way, then our brains or our effort goes toward solving the assumption underneath that. But maybe that wasn't the actual assumption that fits reality. And then if you rewrite the question, suddenly a bunch of effort is put in this
Yeah,
certain category.
yeah.
Very important where a question goes to. Last thing I want to check, if you had a message to all people of the earth about what you do, or what you would want them to know, or what something you think is important, what would you say to all people?
I would say many people who think about this or who hear about this stuff of consciousness,
Hmm.
right, have an impression of some kind of interesting philosophical question, something to think about, kind of dorm room philosophy. But this is possibly one of the most important topics for our species because understanding consciousness is leading toward technology, and the technology is transformative technology. So we're talking about building machines that have the kind of consciousness we have. And we're talking about ultimately migrating minds from one platform to another, like from a biological brain to an artificial device. And so we're talking about something that's more transformative than any technology has ever been, right? We're talking about understanding consciousness at an engineering level is the basis for a change that, is bigger than invention of writing or the invention of telecommunications or the computer revolution thus far. We're talking about something fundamentally transformative to who we are. So there's something really pragmatic, really practical, and something that people should be thinking about because the future is coming to us. And if we don't think about it, scary bad things can happen with technology. So this is our future. Understanding consciousness well enough to engineer it is looming at us. It's coming very, very rapidly.
The importance of it is very clear. I find the human mind to be the most interesting thing on the planet. This is the book Rethinking Consciousness by Michael Graziano. I want to thank you for having been on this episode. Very informative about the mind and what we think of consciousness as a term. Glad to have you
Thank
on.
you very much for having me.
This is a great thing. And we are out.